Hello, my name's Alan and welcome to Enots Engineering. This is part 2 in a series of videos making a Warden tool and cutter grinder. So let's recap what we've done so far. We've engraved the table using a CNC machine. We've machined part of the sliding block. The next operation is to fit the block to the table. Now to do this we need to set the block parallel to the table edge. We already have a 0.75 hole through the block, which is 19.05 millimeters, and we already have a 0.75 bar. So if you put the bar through the block and take off half of the diameter, which is 9.525, that leaves a distance from the edge of the table to the edge of the bar as 25.475. Now 25.4 is 1 inch. So if we get two 1 inch packing pieces under here and here and put the bar in the block, that would put the centre line of the block at 1 inch to the edge of the bar, which works out at 35mm to the centre. Then the only thing we need to do is set the left and right of the block. By marking the position of the hole from the drawing and scribing a line across the block, when you get that line in the hole, in the centre of the hole on the table, you know your left-right position is correct. So let's do that. The next job is to mark the position of the hole. So on the drawing it says it should be 31mm from the centre to the centre of the hole. This block is 80, so if I half that's 40, so it should 40 from there to there. I want 31, so 40 take away 31 gives me 9. So we scribe a line 9mm from the edge. I've just marked this up with some black felt tip marker using my caliper. Just mark a line across. Now we know when that line appears in the hole on the table, it's in the right position from left to right. So now we have the bar through the block resting on two 1 inch strips. So when we put the table on the base and get that hole marked in the centre of the hole on the plate, we know that everything's lined up. Bring the bar behind, move it along to the holes in the centre of the plate, and then put a clamp on to hold it in position. I've countersunk the first hole, put the screw in and set it back just to check on the two blocks, resting it on the bar to make sure that the base is still square with the table, and it is. And the next stage is put it back in the drilling machine and drill the other holes. I've now taken the table off, and using the spot marks from the drill I can now line up and drill through, ready for the 4mm tapping. next job is to drill and tap these two holes 5/8 deep for an M5 thread. This is the finished bearing block, or sliding block. I've tapped the final two holes there, hole on the side there, and those are the four holes that hold it to the table. So the next job is to make the washers. We've got two guide bar washers to make, which is 3/4 bar, and four space bar washers from a 5/8 bar. Okay, I've taken the 4-jaw chuck off. When you're taking your chuck off, always put a block of wood on top of the lathe bed, just in case your chuck falls. It prevents any damage to the bed and damage to the chuck. I'll clean the threads with an old toothbrush just to make sure there's no swarf in it. The same in the chuck. Chuck on. Tighten it up. Right, I've put the 3-jaw chuck on. With this 3-jaw chuck, you can alter the settings. So I've got the 5 thou run out on that bar. By changing the chuck position on the 3 screws, I can zero that. So what we do is get the lowest reading and tighten the screw nearer that reading. So that's running out now. 5 thou. Slacken the others off just so they let's just screw here. Now we're up to 4 thou. That's less than 1 thou, half 1 thou. Right, first job is to face the front of the bar off, and then centre drill and drill a hole. should just sink just below the surface. That's okay. And a good tip is, if you've got a tin foil dish, just place it beneath. Make sure the chuck doesn't catch it. That catches most of your swarf, and if you drop anything, it's in the dish. Before I part it off, I put a slight chamfer on the edge to take the sharp edge off and polish the outside diameter. This brush has got just a little bit of engine oil on. I'll put the chamfer on the inside. Parting off tool.
This should measure 0.125, so that's okay.
And when I sharpen this parting off tool, it's only the very tip that I sharpen across the front of the face. I don't touch the sides because they're already pre-formed as part of the tool. The way I've sharpened the tool is I've put a slight slope on the end, so when it cuts through it leaves this bit on here and hopefully gives a clean face on the piece I've parted off. You see that? And there's the first wash.
These are the finish washers which have been heated to make them blue and quenched.
The next part we'll make are the two slide plate clamp screws, which are made from 1-inch bar, and they fit the side of the side plates. I've changed the 3-jaw chuck for a 4-jaw because this bar is about 8 inches long, and with the 3-jaw it's an inch diameter, this bar. The 3-jaw I can't get an inch diameter into the back of the chuck. This being a bigger chuck, I know the bar is being held by at least 3 inches in this chuck, and that means I don't need to fit a steady on the end to support the bar. So the first job is to face off. 0.610. $7.93. I'm just changing the tool from the one at the bottom, which has got a big radius on the end, to this one here, which has got a sharp corner, so I can detail the corners on the screw. Right, the first thing I need to do is reduce this step here to give me a 16th. Just finishing off to size. Now I'm bringing the face to a 16th. This diameter will be threaded near enough, 8.04. So I've machined this to 8mm, 10mm there, 3/4 of an inch there, and I've just taken out the radiuses in the corner, and I'm just going to put a chamfer on the end to give me a leading for the threading. Put the knurl attachment in, I've centred it, come down on the diameter using this screw. Now I'm feeding it into the work, and I've slowed the speed down. Because the knurl I need is a bit bigger than the width of the knurling rollers, just got to move it backwards and forwards a bit. What I'm doing is slowly feeding it in. Right, so I've removed the knurling tool, I've taken the tool post off. The next job is to put the thread on here, which is a 8mm by 1.25 thread. Right, I'm doing the thread. I've brought the tailstock forward just to hold the back of the die square, and as I turn the chuck, the thread will start to cut. You need to feed in the tailstock as you're turning the chuck. Then every now and again just back it off half a turn. And this keeps the die square, gives you a square thread. It's a bit awkward with the camera in the way, but you can see the method. This die is a solid die, it's not got a split in it, so you can't adjust the thread on it. Some dies have a split, and by tightening the centre screw you can open the die up to give you a tight thread, or you can close it by tightening the outside ones to give you a loose thread. And that's a thread cut. Still getting a lot of chatter, but what I'll do is use another tool just to put a chamfer on the inside edge, so that screw is virtually finished except for parting off. So all I need now is to part that off, face up the end, and it's finished. I don't want to take the bar out the chuck because it's already centred and true, so looks as if I'll have to use a hacksaw to cut that off because of the chatter.
I finished the second clamp screw. Now I've changed to a 3-jaw chuck, and I'm holding the clamp screw with a couple of nuts on the thread so I can face the end off on both clamp screws.
That's the second one done. Two clamp screws.
Well, thanks for watching. I hope you've enjoyed it, and we'll see you next time on Enots Engineering.